Hi, I'd like to make a case for increased use of event buses, in particular one that I've created on top of RxJS called Omnibus, as a core solution in modern front-end web architecture. I think it'll allow us to build more sophisticated apps and applications with less resource leakage and fewer race conditions, with less effort. So let's get on board. Why an event bus? Why should that not be a scary concept? Well, backend developers use events like Apache Kafka to decouple services, and that works. It works at scale, and it works to decouple. Our modern front-end web applications could have something like this in them, and it would be a familiar concept. Maybe the DOMs own events? Yeah, but they're not portable to mobile platforms, and cancellation of bubbling and propagation, it's not necessary. So, what problems could you solve by using an event bus, particularly Omnibus? Number one, framework dependence. And the point here is that all web frameworks really need to do on the web is take state changes and put them into the DOM. They don't need to handle async. And yet each one does in its own way. And that causes a fractioning of our vocabulary that we use, and it causes us to be vulnerable to major framework releases, where we could put all of our async onto a bus that works well and have framework independence, as well as fewer race conditions and resource leaks, which I will demonstrate. And if you think that promises running to completion is not a resource leak, well, it's okay, because you can certainly build a lot of applications out of promises that are very valuable and good applications, but that would be having a pretty low bar for what is like acceptable. So I think that if you have a low bar, that's fine, but you'll often end up tripping on it. So the idea here is to raise the bar so that our applications get better with fewer resource leaks and race conditions. These things that are just, only the final 2% needed to finish an application, but we can build them in from the start and end up with getting more sophisticated applications with less work. And what I mean by more sophisticated is that most modern day web apps suffer from an assumed request response behavior. We have a cognitive bias that makes us think that the web is all about I give a request, I get a response in one-to-one correspondence. But because our tools only heavily favor this response, it costs us excessively to move out of that paradigm, such as by incorporating streaming stock tickers, or getting full duplex communication over WebSockets, or any time that we have daemon-like or batched response-like behavior that doesn't work with every request has an awaitable promise with it. It just doesn't scale. So in this talk, I'm going to move away from talking now and show you how to build stuff in this style, show these problems getting solved in real time, resource leaks, race conditions, and we'll be doing this in vanilla JavaScript, so it'll of course be portable. And what we'll end up having built is a counter that has just enough features to make it useful. It has synchronous incrementing, and it has asynchronous incrementing, 2 seconds, and it increments. And it has a very helpful console so that we can just see what's going on when an increment async turns into a counter increment. So we'll build this and it'll be a lot of fun. So let's get started in a vanilla JavaScript app where we have a document with a bunch of buttons that have no behavior hooked up to them yet. You won't see anything going on in the console, no state, no bus, no events. And we'll make this work with a bus. So the bus is going to be very simply an import, and then an instantiation and some TypeScript hints and a spy to put every message on the bus to the console so we can see it. You don't need Redux DevTools if you have a SPI that dumps to the console. Then we are going to have a service that we'll talk to, and the service declares that there's two ways to interface it. You can send it an increment action or an increment async action, and eventually it'll do the right thing to dispatch increment after increment async. We'll get there. And eventually it will be able to unlisten as well. Okay, so let's get on with building a useful async counter in this Omnibus evented style. So what we need to do to get some events on the bus is to call bus.trigger with an event. So we have just put those in and no other behavior, but we do have a counter increment going to the console every time we click because we are spying on events on the bus. So that gets us started. But now, how do we get a state change to happen? Well, here we have the function that can move the value of count into the DOM. Okay, so I think all that we need to do is listen for those increment events. And listen takes a criteria, and the criteria is that we are going to match the increment event. This returns a predicate function. And then when we match the increment event, well, we can just update count in DOM, the incremented count. And even if this feels a little dirty to do, this really does work. Now, I'm not showing you how to update the DOM directly because I'm insisting it's a best practice everywhere. I'm just showing that these event listeners are highly decoupled from how you keep state. They're essentially unopinionated about it, and so you can really use any state management paradigm you want with Omnibus. Now, we are going to need to graduate from sync to async to demonstrate the rest of the features, the cancellation ability when we click on listen, and the concurrency strategies which use RxJS operators when we have multiple of them in flight. So let's keep going. Okay, increment async. Our goal is going to be to take an increment async action from the bus and then run a listener that puts increment on the bus just a little bit later. So we can get started here. We can say there's an async listener, and when we listen for what? The increment async action, so the match function. And then what are we going to do? This is going to be the effect. And then when the effect has lifecycle events, what are we going to do with those events? Okay, so the next step here is to run the effect, and we'll just use this placeholder function called after, which our effect is going to be to wait 2000 milliseconds and nothing else. Okay, we'll return it because it's a good idea to return the work. And then our observer, what is our observer going to do with the information that this effect just completed? Well, we're going to just handle the complete event by triggering an increment. We can go here and increment async once, and we'll get one increment. Awesome. But we're really only showing you that this is possible so that we can dive into resource usage. So when I click unlisten, it'd be great if I could cancel this operation that's in progress. And I mean not only cancel the update that's going to make this 2, but if there's real effects going on, like an AJAX call, then I want to be able to cancel those AJAX calls too. So this is possible. In order to make that happen, we want to wire up an unlisten function to our DOM, our unlisten link there. We want to call unlisten. And then what do we have to do in this unlisten function? Well, this async listener, we can just call unsubscribe on it. That will stop listening. And if our events meet a certain criteria, it'll stop the events too. So first let's test this with our timing events. We do increment async, and while that's on the way, we do an unlisten, and what do you know? It never occurs because we canceled, so that's good. But if we were running Ajax, would it have canceled it? And the answer is, it depends. If we were using a promise-based implementation of Ajax, it would not. So for example, if we did fetch this URL that delays for 2 seconds, and let's open this up in a new tab so that we can get at the network. And the network here is going to look at XHRs where we do a increment async, all right? And there it's doing a fetch for 2 seconds until it updates the state. And then if we do an unlisten, what you're going to see is we will not go to 2, and that's good, but we will continue running our XHR to completion, as promises tend to do. Going upwards, canceling, we don't get to 2, we do have to run this promise to completion. That's the resource leakage that is occupying some resources that we might as well free up, because we know we're not going to be updating the state with it, so could we just cancel it? And the fact is, we certainly can. And the good news is that it's not going to take much additional effort. We returned a promise, but we didn't have to. There's another API that comes from the RxJS library that returns an observable. And guess what? Observables themselves are cancelable. So if we have an observable XHR running and we click increment async and unlisten in the middle of it, boom, we're canceled. And we never get to 1. I think if you want to fall into the pit of success with resource utilization, it's good to just cancel. Just like Unix processes cancel their child processes when they're terminated, these processes, these effects are bound to the listener so that when the listener is unsubscribed, so are the processes. And returning cancelable processes has other benefits too when we get to concurrency strategies. Now, as we're in the listening mode, if I begin an increment async and then I begin several more, they're all going at once, okay? And that might not be what we want. For certain UXs, it's absolutely not what we want. Maybe we only want to have 1 in progress. Each one of these strategies applies to a different UX category. And queuing is one that you can use to just make sure that there's only a single going on at once. Now, a single increment async and several more will still have each increment separated by the same amount of time because there's a queue. And if this was doing real Ajax, you would see the request completely waterfalling. I can make this dynamic so that I can actually click on these modes. Just bear with me a second here. The strategy comes from the URL, and we will just call the method that corresponds to the strategy. Little editing problem here. Bus strategy. And now we can take you through the modes, such as listen switching. That's going to be one that is like a debounce. We are in this mode, and I do increment async, but then I keep pressing it. Well, they don't queue up, and they don't all simultaneously execute. They kind of wait until I'm done pressing the button to allow the increment to come through. That's like a debounce. Listen blocking is like a throttle. I click once, several more times during. The first one completes, the other ones were ignored. Between all of these modes, you're covered for whatever kind of paradigm you could have to code against. So these features of cancellation and concurrency strategies, they're just, if they're hard to use, you won't use them. If they impact the architecture greatly, they'll be expensive. If they're easy to implement and easy to just change with leaving all the rest of the architecture intact, then you'll be able to make those top-notch UXs with whatever timing you want just easier and with fewer race conditions. And you'll do it outside of any framework. This is Omnibus library is an 8 kilobyte version of an event bus. It is just a thin wrapper around RxJS, and it just has an API that can be utilized in Svelte, Vue, Angular, React, or Vanilla.js. So it's not a huge weight to add to your bundle. It does something really well with all the performance and testability of RxJS. And so I highly recommend you give this library a try for all of your async needs. There's a lot more in the documentation, including ways to bundle up the behavior with a reducer so that we actually can keep track of the state in the service. That might be a more familiar paradigm if you've worked with certain Redux middlewares or a store that does async as well. Having a reducer is something Omnibus certainly supports. And then you can get to a place where your state object or your state tree, all you do at runtime to bind it to your framework is just subscribe to the state of the async increment service and update the count in DOM whenever it changes. And then we also have in this service an isActive observable, which makes sure that anytime you are doing an increment async, your spinner is showing. And of course, because this is all bundled together and highly tested, you'll never have one of those bugs where when you unlisten, it forgets to turn off the spinner. That just can't happen. These things are written in such a way that you have guarantees. So I hope you enjoy it. Please let me know what you think in the comments.